I want to look at the problem of dealing with a function which is declared 3 times in these 3 classes. So the function describe is implemented in 3 different ways, once for bookob, once for horror bookob, and once for ref bookob. It returns a string which provides information on the name and the author for each of the 3 types of books. It also returns information on the Go score for the horror book and of the ref type for the ref book. So let's just see this in action. This is the project called bookprob because I've deliberately put in a problem here that I want to explain how to deal with. So I'm going to use very simple book titles for speed here. So my general fiction book will be called G and the author will be called GA. I add my book. I add a horror book. I'll call that H. Author I'll call HA. Just giving these names for speed of entering. And finally the reference book R and RA. Add the output that's displayed in the memo shows that the horror bookob create has been called and the ref bookob create has been called. When each of these is called prior to the create constructor of the specific type of book executing, the bookob create has also been called. That's because, as I explained in the previous video, my code calls the inherited constructor in the constructor of the descendant classes. So that's as expected. So I'm now expecting to have a list with 1 bookob, 1 horror bookob, and 1 ref bookob. So when I show the books, I'm expecting the describe method of each of those types of bookob to show me the data relevant to the books. Let's see what it does. This is the problem. Even though I've created books of 3 different types, when I call describe, I'm only getting the information of the general book. That's the basic base bookob, not of horror bookob and ref bookob. Let's have a look at my code. So this is the function that executes when I click the button to show the list. Now the list here is of type TList. It's a simple list manipulation class that's provided by object Pascal, and it can contain objects. It actually points to a list of objects of potentially different types, and in fact that's what I've got here. I've got a mixed list. I've got 1 bookob, 1 horror bookob, 1 ref bookob. So as the for loop here wants to call describe, it first has to cast the item at each index in the list to a bookob. That is, it has to tell the compiler, treat this item as a bookob object, because the list itself, the T-list, is capable of containing items of any type, and items of other types will not have a describe function. So the syntax for telling the compiler to treat it as a particular class type is this. I put the class name, then I put what I want to be treated as an object of that type between parentheses. Now the compiler knows it must treat this as a bookob object, and so it calls the describe method that is defined for that bookob object. Bookob is compatible as the base class with each of its descendants. So this will work, this code is perfectly permissible to call describe on bookob or its descendants, horror bookob or ref bookob. But the problem is, when I do this, it only ever calls the describe method defined for the base class. That's bookob. It does not call the separate describe methods for its descendant classes. Let's look at those methods down here. So for ref bookob, what I'm expecting is the result to be returned showing, first of all, reference book, and then the name, author, and ref type. For horror bookob, I'm expecting first horror book, followed by name, author, and Go score. And finally, for the basic bookob, I'm just expecting general book, followed by name and author. But this one is the only one that's ever being called. So let's look back again to remind you of what the problem is. And the problem happens here when my objects, all the objects in the list, in oblist, are specifically cast to the bookob type, and it's bookob.describe that is called. And I want the appropriate describe for each particular class in the class hierarchy. So how can I solve that problem? Well, here's my first attempt to solve this problem. This is, again, the bookobs project. And let's just try it out, see if my solution works. So general fiction, G, author, GA, add book, horror, HA, add book, and reference, R, RA, add book. The constructors are called as before, so the books have been created and added to my list. Let's see what happens when I show the books. Hurrah! So this time it succeeded, because the general book shows the name and author, the horror book shows the name, author and gore score, and the reference book shows name, author and the book type. So that shows that the describe methods, the 3 different describe methods for each of those 3 classes, has been correctly called. How did I do it? Right, this is my rewritten show ob list. So this time what I do is, instead of casting to the bookob type, I cast in the for loop to the T object type, which is the base class. It's the ultimate ancestor of all other classes. So that's always going to work. And then as I iterate through the items, I test. And I use a special test operator called is, and that tests if it's a horror book. Then I call, and I cast this time to horror bookob, and call the horror bookob describe method. Otherwise, I test if it's a ref bookob, and if so, I cast to ref bookob, and well, you get the gist. So it works, and for a small and relatively simple program like this, it's maybe not too complicated, but it's not really very elegant. There's a better way of doing this, and I want to show you what that way is next. So this is my final attempt at solving this problem. This is in the project bookobs 2. Let me quickly run it and go through the same tests as before. General fiction, GA, add book, horror, HA, add book, and reference, RA, add book, show books, and sure enough it shows the particular type of object of each book: general book, horror book, reference book, and it displays the formatted string that's returned by describe for each of those 3 class types. So let's now look at the function, or the procedure rather, show ob list. This is the one that iterates through the list. Now this one is back to the simple version. I'm no longer testing each object for whether it's a bookob, a horror bookob, or a ref bookob, and then casting them one by one. This is back to the simpler version, where I simply go through the ob list, and at each index I call describe on the item, having first cast it to the base bookob type. But remember, when I did that before, I was always getting bookob describe called, not horror bookob when it was a horror book object, and not ref bookob when in fact the item at that index in the list was of the reference bookob type. So given the fact that this code caused problems before, how is it that now it is displaying the correct information? It's calling the correct version of describe. It all comes down to the simple way in which I have declared the describe method. Look, here you can see in the base class, in bookob, the describe function has been called virtual. I've appended the keyword virtual after the declaration. That has profound effects on the way that that function is invoked in my code. Look now at horror bookob. When I declare describe here, I mark it with override. When a method has been declared as virtual in a base class, and a method with the same name is declared in a descendant class, I can mark it as being overridden. That's what I've done here. So I'm saying replace one definition with the other when I'm working with a specific type of bookob object. So when horror bookob is being used, use its own describe function. And similarly, with ref bookob, that too is marked as overridden. So the effect of that is that when I now call describe on the bookob type, in effect the describe method is looked up. A search is made to see if there is a specific version of describe for the particular type of bookob that I'm working with. So even though I've cast it to the base type bookob, describe is called with the describe method that is declared on the actual type. So if this bookob is a horror bookob object, horror bookob describe is called. If this bookob is a ref bookob object, ref bookob describe is called. And that's entirely due to the fact that I have declared describe as virtual and I have overridden it. One final point. Look at destructor. Destructor destroy is marked as override. Why is that? Well, unlike create, the constructor, the destructor is a virtual method. And when you declare your own destructors, when you declare destructor destroy, it must be marked as override. Bear in mind what you've just learnt about the way that virtual methods work. Think now about how the destructor is normally called. As I've said before, you normally call the destructor by calling the free method, and it calls the destroy destructor. So you call my object .free, and the free method calls whichever version of destroy is appropriate to a given object. That means that just as the correct version of describe is called for each particular type of object when I iterate through my list, the correct version of destroy will be called for each particular object when you call free to remove that object, to destroy that object in your own code.